Hi my friends, today we model this part with the name fixing clamp, which I found on the net. You see the pictures. This is a view, this is another view from the bottom. The screws are 4 with a length of 30. Another view is this one and another one is this one. We try to model this sheet metal part. The drawing is here. I made it for you, of course, with the flat pattern here, but I forgot to write here flat pattern, so let me write here flat pattern. Okay. Good. What we have here? We have a mid connection plate with 2 flanges on the left, 1 to the right, and on the bottom other 3 flanges. Total 6 flanges. A problem can be creation of this punch or cut here, but let's start with creating of the main part. New sheet metal, start sketch, this plane, rectangle, dimensions 40 on 10, with the midpoint of the bottom line placed in the center point of the sketch. Finish sketch. Sheet metal defaults. The thickness is not 0.5 but 0.8 millimeters. We use this dimension to create a face, the first volume of our model. The material is stainless steel, so we have a start now. If we take a look at the drawing, we see the thickness 0.8 and we see this 40 on 10 millimeters for the mid part, the connection wall of this part. Good. Let's continue with this first flange, which has a bend here. Dimensions are 9.5 at an angle of 12. But if I measure from the right, this is 90 plus 12. So let's apply the tool flange, which is placed by having this reference, this edge. The angle is 90 plus 12. The distance is 9.5, and we have an extension of width, not centered but offset, measured from the left with 0 as a start and 12.5 width. The length or distance is this one, and we use these two options, measuring from the adjacent face, and the other option is to start from a tangent plane. Okay, we continue with this edge, flange, and we consider now the value of 3.5 as a distance, 36 the angle, and another option here and another option here to respect dimensions in the drawing. We don't need to select anything else here because we use the full edge from there. Okay, now I create this flange, this one, you see a dimension here, 12.5, the width of the flange. This one is 10 millimeters from the left face of the face, and the width 12.5. Flange, this edge 90 degrees, then measure from here, the distance is 10, and the other option is this one, and now we have to use the same procedure, measuring from the left of 12.5. From the left means 0 from the left. Okay, now I apply corner round of 1 millimeter to this edge, this edge, this and this. Okay, you see that dimensions here, radius 1 all over. Good. I mirror these flanges to the right by using the plane XY. XY is the mid-plane of the part. Mirror, this is the mirror plane, and the features are 1, 2, 3, 4. Mirror plane is the plane XY. Okay, you see what happens here. And you notice that some cuts appear by default to make this part with the proper tools. Okay, next is this flange, which has the same dimensions like on the left, 9.5, 9.5, 3.5, 3.5, angles 36 and 12, 12 over 90. The width is 13.4, which means all the edge, all the available edge. Look here. Flange, edge, 90 plus 12, 9.5. Selections are this and this, and we don't need other options here because all the edge, which is 13.4, is used. Okay. Another flange from here at an angle of 36 with a distance of 3.5 with the other options like before, which were these two. Okay. The last flange is here. We'll use this edge. Its dimension are 12 instead of 10. Okay, let's apply this dimension. Flange based on this edge, the angle of 90, the length of 12, the options like before. Okay. We apply corner round of 1 millimeter to the new flanges and to respect the drawing. Okay. Good. There are some holes here. Yes? What holes? Let's take a look here. Two holes of 4 millimeters at a distance of 4 and a distance of 27.5 between them. 4 millimeters, 27.5 and diameter of 4. We select this face, we create a sketch, we draw a line, a vertical line with a length of 27.5. Then the dimension of 4 millimeters from the right, F7 to see inside, because we have to place on the same horizontal the center point with the midpoint of the line, because everything is symmetrical about this axis. Finish sketch, no finish sketch, but I can apply here a point, work point, and another work point, another work point, instead of placing points in the sketch, my friends. To apply hole, and these 2 points with this direction, diameter of 4 millimeters, but I want to select this and I cannot do this. Four millimeters plus another hole placed here with the direction and OK. The sketch is not consumed, so I make it not visible. Good. You can create everything in the sketch, but I forgot it, so we used another way. The last is that tricky object feature which cannot be flattened. Yes, you see, if we go to our model part, we can create a flat pattern very easily. This is the flat pattern. We'll see what is the flat pattern after we place that last feature. To create it, we use the same plane XY to create a sketch, a complementary or help sketch. And the plane is this, and we apply F7 to see inside, and we draw some lines here. But first I project 1, 2 lines. I start from the upper one to draw a sloped line, then back perpendicular on the last and on the bottom projected line. We also draw a line, but not from any center like this one, a vertical small line. We dimension this line at 5 millimeters from the left. 5. Now I make it center line. I place an angle here of 90 divided by 2. I dimension the thickness with the value of the thickness. We know that since we use sheet metal template, we have the thickness as a parameter at our disposition. Thickness is 0.8. 0.8. Another dimension, let's see where is the source for all these dimensions. 90 is the angle, 2.3 is this, and 4.2 is the small horizontal line. Let's apply 2.3 from the face to the bottom. 2.3, and the diameter of 4.2 is about this axis at 5 millimeters. Where is 5 millimeters? 5 millimeters is here. Yes? Okay. Now I create a dimension. We created this only for this dimension. We don't use this sketch now. We create a dimension from this point to the center point with the value of a driven dimension. This is a driven dimension. I accept this. Oh, very interesting. This is a result of this construction. 0.8331, everything. You can change the precision to have this value, no problem. Finish sketch. We project a point at this end of the vertical center line, and now we proceed like before to apply hole with this center, with this direction to the bottom of diameter. You see, this is selected, so I can select this to use the value. You understand this? Yes, you are my pupils, my students. You understand everything, my friends. Now I hide the sketch and the point. These two are no more necessary to be visible. I forgot, this must be visible. The sketch must be visible. Why? To create another sketch, my friends. XY is the plane, F7, and I project some lines which are the axis. I don't want to forget it. This line 2, 3, 1, 2, 3, and also this one. And I close this contour by drawing a line by hand. Now I have a closed contour here. Finish sketch. Now I hide the former sketch. Now it is not necessary. And I have a center line. You see, this is a center line and a closed contour. What to do with this? We do a revolve, but not from this environment, not this ribbon, but the 3D model ribbon. Revolve, everything is defined here, so we have the result. You see? Okay. Oh, but there are some curves here, or fillets. They are present and we have to respect them. This radius is by default the thickness, and this radius is the thickness, the radius of bending plus the thickness. We use this to apply the tool fillet also from the 3D model environment and not sheet metal environment. Fillet this edge, and I select from the list of parameters the bend radius, which is equal with the thickness, but this is the definition. Plus, again, I select from the list of parameters the thickness, my friends. Oh, this will be the next, not now. Now I don't use this. Bend radius. Okay. Here we apply fillet with that expression bend radius plus the thickness. Okay, now is finished the part, my friends. A lovely small part with a lot of flanges. Let's see what about the volume. Eye properties, physical, update, select this value, copy, close, go to the drawing, double click here, and now you see 3 is here. This is the power, cubic millimeters. Paste, and we have the same value, 1052.642 millimeters at the power 3. Cancel. We have that value. We already have the value. Cancel. And that's all for today. Thanks for watching. Bye bye.